So the main goal of analysis of variance is differences in means of multiple groups. And when we talk of multiple group here, we are saying we are dealing with a situation whereby we have more than two situations, unlike t-test, where we are dealing with binary situation. In this case, we are dealing with more than two. So this lecture describes the different types of analysis of variance, but specifically we are going to focus on estimating one-way analysis of variance. And we're going to use specific examples and illustrate how to do it. When we talk of one-way analysis of variance, it's just an extension of the sample t-test that we've done. So this is a situation whereby we are comparing the means of more than two groups. It's the simplest case of analysis of variance, where we organize the data into several groups according to just one single grouping variable, which means we are grouping them based on just one factor. Just one factor. But when we talk of two-way analysis of variance, then we are evaluating simultaneously two different grouping variables. So the grouping variables actually define the name. So in situation whereby we have one grouping variable, then we have one way. Two grouping variables, we have two way. Three grouping variables, we have three way. It's as clear and simple as that. So that is the simplest way to know what. But for this class, we'll be dealing with one way and two way. The main goal of two-way and three-way analysis of variance is to evaluate if there is interaction effects between the two or three factors that we are dealing with. The case of one way is straightforward. We are just looking at the effect of that one way, of that one factor. When you are dealing with two-way, you are dealing with the effect of each of those variables and their interaction. So in this class, we are going to interpret one-way, two-way analysis of variance using R. We are going to check the analysis of variance test assumptions. We are going to perform diagnostic test in order to compare the group to really know what is actually responsible for the difference. Then, where possible, we try to visualize the data and do some other tests. So what is the rationale between analysis of variance? The idea behind it is very simple. If the average variation between groups is large enough compared to the average variation within groups, then you conclude that at least one group mean is not equal to the other. What we are saying. Take for instance, these three groups. Within the group, there should be some level of differences. And between, that's what I try to illustrate here, the group. So we are comparing the differences among the group and differences within the group. We are looking at the variability among the group and variability within the group and see whether there is any difference. And to remind ourselves, because this is what you're supposed to have done in your undergraduate statistics That is how to compute it manually. So to remind ourselves about the manual computation, we want to do it by hand. The first thing you do is you compute the within group variance. This is what is called residual variance. That is, you calculate the mean for the group, you subtract each value within the group from the mean. You sum over. That is how to calculate that. You square them, then you calculate. Just calculate within group variance. Yeah. Then again, the variance between group means. Then you produce the F statistic, which is the ratio of variance between groups, variance within groups. If you have forgotten how to do it manually, you can pick any statistics, or you just Google. Now, no, we are now in the global village. Just type formula for analysis of the one-way analysis of variance. For example, then you see the way it's done, just to remind yourself. But in this class, my focus is the estimation, the interpretation. Also, actually learn how to do it manually. But because of the kind of volume of data set that we are going to be dealing with at your level, you know you are not going to compute. So, but just to remind everything I've said, just to remind us the video. So, what are the assumptions that I need to understand if I want to use this analysis of variance? Number one, the observations must be independent. Each subject should belong to only one group. There is no relationship between the observations in each group. So situation whereby we have repeated variance for the same participants is not allowed. Second assumption is that you don't want any significant outliers in any cell of your experimental design. Then the data for each design cell should be approximately normally distributed. Then the variance of the outcome variable should be equal in every cell. So we call it homogeneity of variances. So you look at the group variance must be equal. So before computing analysis of variance, the starting point is you have to perform some preliminary tests to check if the assumptions are met. That is the starting point. Anytime you want to. So now, in order to operationalize what we have, as usual, you set your working directory. Then you load the necessary packages. Essential packages are tidyverse of the data length, possible visualization. Then we have ggpub. You have to install this. Use it to create publication-ready plots. You will see how it works. Then we have arm statistics. Pi-friendly R functions. This for calculating our statistical analysis. Or another thing we can do, I think we should add summary tools. We'll add summary tools too. Summary tools. We already have that one. Summary tools. So, statistics. frequency. Sometimes crossed out. Then for one data that we want to use is in this package, Datarium, as the data set we are going to start with. That's the data set we are going to use later. We are starting with cigarette SW. So we need AER. That one is in AER package. So let's go back to the prerequisite package. So we need AER, so that provides figure the correct spelling of cigarette SW, cigarette SW. That's just want to get this data set from it. That's why. So these are the, if there's any other one, then you come back and add it. So the data set that we are going to use is cigarette consumption, panel data of cigarette consumption for 48 US states, covering 1985 and 1995. So you have data for 1985, then you have data for 1995. So it's a data observations on 7 variables for 2 periods, 85 and 1995. For the variables, we have states, year indicating the year, consumer price index, we have population, which is the population of the states. We have packs, which is number of cigarette packs, capital. We have income, which is the personal, nominal personal income in the states. We have tax, the average state, federal, and average local extra taxes for the year. We have price, average price during fiscal year, including sales tax. Then we have tax S, which is average excise taxes for the fiscal year. So those are the variables. Our descriptive statistics, let me explain, then we shift to R to see how it works. Now, we are trying to make states and year grouping variables. That is, let's say we want to group the variable by states, then or group it by year. So if you are grouping it by states, you want to show the levels. If you want to show the levels, this how many states do we have there? This is what we say cigarettes, dollar. If the grouping is by year, if you do this, I think it's going to give us about 45 different states. You group it by year, you are going to have 2 years, just as I said. Now to have our descriptive statistics, we are trying to use summary tools here. So which means we already have, I think, so the starting point, summary tools. So we have summary tools. Then the statistics, it says, I call it stats, I call it whichever name you like. With here is talking of this our data sets. By that is statistics by. In the first one, we say we are grouping by income, state, then we describe. Then by the time we are illustrating it, we see the reason why I want to limit the statistics to mean and standard deviation, because we have so many states. So it's going to be so wieldy that we won't be able to trace it very well. Then I transpose so that the state, which is 45, would be just one column, while I have the mean and the standard deviation against them. So you type your stats, then you get your results. But if year is, if you are using year, definitely you just change, you change income to, sorry, you change state to year in the second one. So let us see how this is done. So let me stop sharing this. And let's now look, let's share the R and see what I'm trying to say. So this is our R studio. Okay. This is loading all the starting points. ID verse, DD probar, statistics, AR, summary. Then it's always good to have write Excel in case you want to write some of your results to Excel. Yeah. So let's run it up to this. You're already familiar with this. Then this is the data set we are talking about. Already familiar with how to bring your data sets to the console. Yeah, so no problem with any of them. And to see the content of the cigarettes, you just put asking question. If you are familiar with that, it's how to get there. R. So run is going to give us information. Yeah, but let's wait. Okay. Yeah. So now it's showing us cigarette consumption description. Panel data on cigarette consumption for 48 continental US data. So you can see data frame containing 48 observations on 7 variables: states, year, CPI, population, income, tax, price, tax. So that's it. So, and in case you are interested in the source, that's online complement to stock and Watsons. So download it and go through it. So to show the levels of, let's say we want to group variables by states. Let us look at the state of the levels of the states. Make state the grouping variable, for instance, let's show the level, run it. So you can see this is showing us all the, this is more than 45, 46, 47, it's 48, not 45, this is 48. You can see the states. See the states, it's just two quotes. But in case we are using year, and run, year is just two. But don't forget, you cannot do ANOVA with is this, because this is just, let's say you want to compare 1985 to 1995, then you'll be using t-test, example of what we did last week. So don't forget, because I'm not saying I will, I may set it as part of your coming test anytime you are ready, so that use t-test to test for the mean difference in certain variables, 1985 and 1995. So that may be a typical question. You do all the necessary tests. We have done that one. So, but today will be an analysis of variance, situation whereby we have more than two groups, such as this state. Now, in this state now, we have 58 different groups. Now coming to the descriptive statistics, like I said, this is stats. Let's say this is, I want to get the statistics of income by state. So let me call it stat states. So this is the data set, ST by income by state, right? Statistics. Let's say I don't add this. Let me delete it, and you see the reason why I have. Let's say, let me copy it so that I will not be retyping. I want to show you the essence of why it is important to maybe reduce the number of statistics and to transpose. So I will remove those transpose and let me remove it. Okay, let's say it's like this. On it. So yeah, so the result is out. So let me show you how the result will look like. Run. So you can see so many, you can see a lot, because the reason is this, is considering all the 45, this row that you are looking at contains 45 different states, and the statistics, as you know, we have the mean, the median, the variance, the standard deviation, and so it's so massive. You can see skewness, kurtosis. So to make it handy, that's why we say, okay, let's just pick mean and standard deviation, letter transpose. So if you have done it this way, that's, so let's run this now. You will see the beauty of limiting the number of statistics. Yeah, you see what I'm saying now. You can see now that it's easy to follow. Yeah. So you can now see this is the one that we have done. This is mean standard deviation, and this is just the list of those 48. Very simple to follow. And let me just remind you, because it's not sometimes, You can export this your result straight away to Microsoft Word, and probably to have set your working directory. Start. Let's set the working directory. I'm using AMC03, that's my directory. So open. So if I've done that one, so simple. Just a view. Make sure you have to view. Make sure you pick the view for summary tools. You pick summary tools view, then start states what you want to move. Man, then give it a name. Then my start states. Then you run it. Oh, sorry. I omitted file. That should be file equals to, yeah, file equals to, that's why it's not admit. A file equals to, which will work now. Yeah, fine. So now to check my results, we have to go to desktop, check the folder, AMC, then I will find my result there in Word format now. Just open it with Microsoft Word. I think you are familiar with it because we've done it in the class. I'm just reminding you. But let me open it. Subsequent ones I will not open to save time. So if I want to open this, I will go to my directory. So I'm use AM603 as my directory. So let me trying to get AM6. Let me open it so that I show you how the result looks like. That's it. Open with Microsoft Word. Okay. Yeah. So let me show you. Let me now share it with you. Let me share it with you. So this is it. So this is how the results look like. So, and definitely, and just yeah, fine. Make message with adjustment. This is how it looks like. Yeah. So let me stop sharing this. Go back to our slide. Um, Let's go. So let's say that is if your grouping is state. But let's say your grouping is year. Yeah, you just have 2 years, so you don't need to transpose or do anything. This is income year, because year is just 1985, 1995. So it's the same width, these are data sets, statistics by. So you do that, let's run it, you should run. Yeah, no, this is very straightforward. You can see. Yeah, 1985, 1995. And if you want, then use view also to Microsoft Word. So that is descriptive statistics that you must first do for your data sets. Very important. Okay. So that is the descriptive statistics. So the next thing we need to do, like I told you, you have to check for different assumptions, because outliers must not be validated. Unnecessary outliers in the data sets. You have to identify outliers. So you try to identify outliers in your dependent variable, in this case, income. Then test for normality assumption. So we test for normality, run linear regression, then you get the plot of the residual. Or another thing, you can do what is called Shapiro normality test for the residual. Then you try to do normality assumption also by group. First do it by pulling everything together. Then you do it by group. You will see the result by the time we look at it. Then test for homogeneity of variance. That's very important. Do that by plotting the residual against the fitted value. It is after you have done all these things, like I said, that you now perform your analysis of variance. So to perform analysis of variance, it's very straightforward. The function is an over test. Then you run the outcome against the grouping. If it's state, it's here income. But no, we can't use here anyway, I told you. Because here is not true. If you are using here, then you are doing t-test. So let's go back and try to see how it works. Okay. So to check for the assumptions, number one, outliers. So you have outlier. First thing is try to identify the outliers for my income. One. This one. See my results plus like. So this is results outlier. So you look at it. What he said, this 11 said is extreme, the answer is 0 rows. So in this case, now we are sure for income variable or any of the variable, we don't have outliers. Because if we have outliers, it's going to tell us where the outliers appear. So you can go back and check your data sets and see what has happened. So that, because if outlier may even be because of the way you have entered the data itself, not be from the sample itself. So you have to understand the source before you think of what to do. But in this case, outlier is not a problem. Then test for normality. Test for normality, we run the regression of income against state, income as a function of state. That equals that. Then we now draw the graph of QQ plots. It's a type plot. So yeah, let's see how it works. Let's see the plots. Yeah. So you look at the plots, you can see that for this plot, some of the points actually fell on the line. If all of them were on the line, then you have the confidence to say that there is no problem that this normality assumption is not validated. So, but in this case, we can see the line. So, most likely, the assumption of normality may be validated, but it's good to conduct further tests to find out, since all the lines were not, all the points were not on the line. So let's try and look at our Shapiro test. That's what we try to do by okay, this EG plot by the one that we've drawn is the, okay, no, sorry, before we come to, so let's try the Shapiro test, residual, sorry, not yet by group now, just the main thing. So Shapiro test or residual of the function we have here. So let's run it. So if you run it now, you see the statistics is 0.929, but our concern is this p-value. When your p-value is less or equal to 0.05, then you have to conclude that the normal assumption is violated. That is even from the graph, I know it's straight away. Yeah, that's how to go through it. Homogeneity of variance, you want to test for that. You have to plot, or let's say I want to do it by grouping. You want to do your Shapiro test, or which want to do the Shapiro test by different groups. So run it this way. Yeah, but I just try to do it by year, but if you do it by states, let's say I want to do it by state, it's going to give us values. So we actually know which state is contributing to the problem. Hey, yeah, in this case, it's complaining because it said the sample size not be more than 5,000. And in our own case, it's more than 5,000. So let us not worry ourselves. So But the most important test you have to carry out is this homogeneity of variance. We want to be sure the variance by different groups are okay. To do that, we just have to plot the residual against the fitted value. That is what we are trying to do. So you run it. Yeah, you can see. So the interpretation of this is this. And I want you can see, it doesn't have any, it doesn't form, you find the point of the lines all over, which means there is no relationship between the fitted value and the residual. So, and in that wise, conclude that the assumption of homogeneity of variance is not violated. So after you have done all these things, then you have to now say, yeah, I want to do my ANOVA. To do the ANOVA, one way ANOVA is very, very straightforward. Get your data sets, your familiar type operator. ANOVA underscore test. That is, what do I want to do with this data set? For what? This income. The one that I want to test for the mean of income by state. That's what I'm trying. So run it. Good. Our interest now is this p-value. We have just check for this p-value. This is 0.00000. It's less than 0.05. So in that wise, we have to reject the hypothesis that differences in the mean of the state are equal. So the means for the different states are different. Then you look at this value, 0.8, is showing that states have variability in the dependent, that is in the income. Variability in the income by different states. No, variability in income is influenced by states. That is 88% variability. This is talking of 88% variability in the income is determined by differences in the states. So state is responsible for 88.2% variability in income. What this one is saying. Try to interpret it in that manner. So now we have the confidence to the different means of different states and say something about them, about the differences and so on. But you have to take it a little bit further by trying to look at which state itself, which states is contributing more to variability in income. What is the difference between different states? That is why this post-hoc test is very, 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 very important. It is called Tukey standard deviation test. So say post-hoc, segregate this, do that, run. So it's going to break everything. Okay, I call it post-test. Let me post-test. Let's run. Yeah, you can see. Now you can see the grouping AL against AR, AL against AZ, and so on. That is showing, is pairing the states and now trying to estimate the differences. So, and you have to look at the estimates, but the most important thing is the p-value. can see, no, it's because of space. We don't have the p-value. That is why I say, okay, let us export it to Excel. This is what I try to do. Right on that LS, then move it to Excel so that you can see the result clearly. So the results has been moved to Excel. If I want to see the Excel, then I have to go to my working directory. So let's look at the results so that we can look at the P, because the P value matters. So that where the means are different. So this is it here. So you can see NS means not significant. Where you have stars means the mean of those states different. You look at the mean income of AL, for instance, against CA, the mean of those, the mean income in those states are different. For AL and CO, the mean incomes are not different. So that's the way to look at it and interpret conveniently. Can you see the Excel? Hello there. Can you see the Excel that I've shared?
No, Prof, we can't see. We can just see the R.
Oh, that I can sense that it's not showing. I'm just sitting down there. Maybe you are.
Yeah, it's not showing. It's only the R that is appearing.
Okay, yeah, let me show you. So, yeah, you can see now.
Yes, Prof.
Okay.
We can see the Excel now.
That's all right. So this is the result. The most important thing you have to look for is p-value here at this level. NS means not significant. Where you have stars, it's showing that the mean of those states. Like you look at the mean for AL and CA, it's different. AL and CO, not. So on and so forth. Before all these ones not significant until you get to New York and want to believe it's Alabama. So you can see the difference. So that's how to, so that you can know. Yes, overall, we can say that states actually influence. We have variability in income depends on states or which states. So you have to really identify the state where you have a difference. And if you look at your data, you can get the mean for different states and compare. Very straightforward to do. So that is. So that's that about one page. We lost coming. We have to wait.